Identifying geometric sequences. So our sequence is 27, 9, 3, 1, and 1/3. So to find the ratio of the sequence, we're going to want to divide A2 by A1. So 9 divided by 27, which would equal 1/3. We want to do the same thing with A3 and A2. So 3 divided by 9 equals 1/3, and then keep going. 1 divided by 3 is 1/3, and then 1/3 divided by 1 is 1/3. So the common ratio of the geometric sequence is 1/3, which means that this is in fact a geometric sequence. Core concept rule for a geometric sequence. The formula is AN equals A1R to the n minus 1. So I'm going to go ahead and write the formula down. AN equals A1R n minus 1. Now we're writing a rule for the nth term. So our sequence is 3, 15, 75, 375, and we're going to find an A9. So we know that we have to have A1, so we're going to look at the sequence and look right here to find A1. So A1 equals 3. Now we have to find the ratio. So we're going to go A2 divided by A1, which is 15 divided by 3, which equals 5. A3 divided by A2, which is 75 divided by 15, which equals 5. So our common ratio is 5. So we're going to plug those two things into our formula. So we get 3 times 5 to the n minus 1. So now that we're looking for A9, we have to plug 9 in for n. So we're going to go 3 times 5 to the 9th minus 1. So we're going to go ahead, and that's going to be 3 to the times 5 to the 8th, which equals 1171875. Writing a rule given a term and a common ratio. So they give us the term A3, which is 4, and the ratio of 2. I'm going to go ahead and write down the formula, which is AN equals A1R to the n minus 1. So what we're going to have to do is we have to get the first 6 terms. So to find A1, we have to go A3 equals A1 times the ratio of 2 to the 3rd minus 1, which gives us 4 equals A1 times 2 to the 2nd, and then that gives us 4 equals A1 times 4, and we're going to divide each side by 4. So then that gives us 1 equals A1. So A1 equals 1, so that's our first term. And we're going to have to find the second term as well. So we have to go AN equals 1 times 2 to the 2 minus 1. So that gives us A2 equals 2. So now we're going to we have A3 already, so we have A1 equals 1, A2 equals 2, and A3 equals 4. So now we're going to have to go ahead and do A4 to find the term. So we're going to go A4 equals 1 times 2 to the 4 minus 1, which gives us A4 equals 2 times 3, which gives us A4 equals 8. So now we have A4 equals 8. Again, for A5 equals 1 times 2, 5 minus 1. A5 equals 2 times 4. That gives us 16. A5 gives us 16. A6 equals 1, 2, 6 minus 1. That's going to give us 2 times 5, which is going to give us 32. And that gives us our 6th term. So A1 is 1, A2 is 2, A3 is 4, A4 is 8, A5 is 16, A6 is 32. Now we're gonna have to graph all of the problems, and this is what it looks like graphed.
Writing a rule given two terms. They gave us two terms, which is A second is 12 and A4 is 3. You have to write down the geometric formula, which is AN equals A1 times R and N minus 1. And you have to put A second and A1 times R 2 minus 1. A second is 12 and A1 times R is 1. Divide R both sides, which is 12 over R equals A1, and do the same way with on the other side. A equals A1 times R minus N minus 1. A4 equals A1 times R with 4 minus 1. A4 is 3 and A1 times R is R to the third power. We know A first is 12 over R, so replace to this side. So which is 3 equals 12 R times R third power. Cross out this 2 and you get 3 equals 12 R to the second power. Divide 12 both sides, then you get 1/4 equals R to the second power. Do the square root both sides, then you get R equals 1/2. We found R, and now we have to find A1. Use same formula, but use this one. So A second is 12 equals A1, which we don't know, but R is 1/2, and 2 minus 1. 12 equals A1 times 1/2 times 2 both sides, and A1 is 24. We found A1 and R, so we have to write down the formula down. So AN equals 24 times 1/2 and N minus 1.
Solving a real-life problem. You are buying a new car. You take out a 5-year loan for $15,000. The annual interest rate of the loan is 4%. Calculate the monthly payment. So this is the formula to calculate the monthly payment. So I'm gonna go ahead and write that down. M equals L over T, sigma notation, K equals 1 over 1 plus I to the K. So first, what we're gonna wanna do is plug everything in. So our L is going to equal 15,000. We're going to want to find I. So to find I, we need the 4%. So we're gonna go 0.04 over 12, and that is gonna give us 0.003. We want to find T. T is gonna be our 5-year loan times 12. So 5 times 12 equals 60. So now that we have all the information, we can go ahead and plug everything into the equation. So we have 15,000 over 60, sigma notation, K equals 1 over 1 plus 0.003 to the K. So after we have that, you're gonna go ahead and divide 15 by everything, and the monthly payment's gonna come out to $276.25.
Finding partial sums. 1/2 plus 1/6 plus 1 over 18 plus 1 over 54 plus 1 over 162 plus something. So we have to find S1. S1 is 1/2, which is 0.5. S2 is 1/2 plus 1/6, which is 0.67. S3 is 1/2 plus 1/6 plus 1/18, which is 0.72. S4 is 1/2 plus 1/6 plus 1/18 plus 1/54, which is 0.74. And S5 is 1/2 plus 1/6 plus 1/18 plus 1/54 plus 1/164, which is 0.75. If we graph, then we get this graph. Core concept. The sum of an infinite geometric series. The formula is S is A1 divided by 1 minus R. Alright. Finding sums of infinite geometric series. 1 plus 3 plus 9 plus 27 plus something, something, something. First, we have to write down the formula. Alright. After that, we have to plug in A1 and R. A1 is 1, R is 1/3. So S is 1 divided by 1 minus 1/3, which is 1 divided by 2/3. S is 1 times 3 divided by 2, which is 3 to the 3, 2.